Spatial Organization of the Micromollusc Community under Recreational Load. In this presentation, our goal is to offer you a quick summary of the research and conclusions. Please follow the links to review the research in further details. Thanks to all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share, and subscribe. The recreational load is an important factor in transforming the living conditions of living organisms in the urban environment. This article examines the role of recreation as a driver of the changing habitat of soil micromolluscs in the park environment and in an urban landscape. The hypothesis that recreational exposure changes the hierarchical organization of the spatial distribution of the micromollusc community was tested. An experimental polygon was located in Novolex-Andrevsky Park in Melitopol, Ukraine, and represented 7 transects with 18 test points in each. The set of soil properties explained 24.7% of the variation in the mollusk community. The distance from trees was able to explain 6.8% of mollusk community variation. The distance from recreational pathways was able to explain 12.2% of the variation in the mollusk community. The spatial eigenfunctions were able to explain 54.2% of mollusk community variation. The spatial patterns of variation in the structure of the assemblage of mollusks were found to be due to various causes. Thus, in summary, the broad-scale component was due to the distance from trees and the distance from the recreational pathways, and was associated with the variability of soil penetration, resistance, aggregate structure, electrical conductivity, soil moisture, and density. The recreational load is the cause of this pattern formation. In turn, the medium-scale component reflected the influence of soil aggregate composition on the mollusk community and components independent of soil properties. The fine-scale component reflected the variability of the mollusk community, which was independent of soil properties.